Here we're going to talk about strategies in repeated games. And so if we consider this stage game, which is the running example being used, the coordination game, where both players have the same action sets to either choose a sports movie or a comedy. Once we repeat that game twice, we can represent this game as an extensive form game. We don't have to, we can. In a way, this is just a more compact way of writing that, okay? Now, that doesn't mean that they're not equivalent. And to that sense, a strategy in an extensive form game from a previous video is something that must match information sets to choices of actions. And so, for example, for Bob, we need to have something that maps this information set to a choice of actions, this information set to a choice of actions, this information set to a choice of actions, this and this information sets to choices of actions. And to be clear, those choices of actions don't have to be specific actions. They can be probability distributions over this action set here. Now, mapping information sets to choices of actions, vectors indexed by information sets, as we've said in a previous video, in the case of a repeated game, corresponds to mapping histories of play. So if we know what everyone's done, we can map them to actions. And so an equivalent way of doing this would be, and I'm going to write down a strategy. So the first strategy for the row player, would be given no history of play, so both players have done nothing. And to be clear, that's equivalent to us being, for the row player, at this node. Okay. Given that we're there, or given that both players have chosen a sports movie, so for the row player, this means that we are here because the row player has chosen a sports movie, and the column player has chosen a sports movie. So we are here. Or given a comedy and a sports movie, which the comedy and the sports movie would mean that they've chosen a comedy, they've chosen a sports movie. That would correspond to this node here. The ordering doesn't matter, of course, or given a sports movie and a comedy, or finally given two comedies. And so these are another way of writing down A1, A2, A3, A4, and A5. Sorry, A0, A1, A2, A3, A4. It's because those are equivalent to the histories of plays that got us to those points. And so a strategy would be just to map those to choices from the action set. Now I could map those to probability distributions over the action set, or I'm just going to write down, well, we choose sports, choose comedy, choose sports, choose comedy, or choose sports. So that would mean that Alice chooses sports at this node. At this node, so if they're here, if they know that the first time they went to the cinema with Bob, they both went to see sports, then they'll choose comedy next time. And if they've both chosen comedy, then they will choose sports this time. And we can read out the other ones. And we can do the same for a column player. So for the column player, we'll have the same histories of play. Now, that might not be immediately evident why the histories of play will be the same, because these histories of play don't necessarily correspond to the same nodes. They correspond to nodes for the column player. So for example, when nothing has been played, that corresponds to this information set when we know nothing. When both players have played sports, that corresponds to this information set because they've both chosen sports. Bob at this stage does not know what Alice has picked, so we are here. Sports and comedy, this one corresponds to this one, and so on. And so another strategy would be S, C, C, S, S. And these are just two strategies. We don't know the outcome yet. They're just two strategies made by these players. And what we can do is we can look at, all right, now if I put this against this, what happens? Well, when no one has played anything yet, they both choose sport and sport. So we get to this game here. And now if we've both chosen sport, we are here, which corresponds to both choosing sport. So now we know that Alice chooses comedy. But let's find out what Bob chooses. Bob chooses comedy as well. And so we end up at this particular outcome down here, which is 5. 5 corresponds to 0, 4. And in general, a strategy has to be a mapping from all possible histories of plays to actions. Note that some of these are not possible. Some of these histories of plays are not possible. For example, if the role player opens by playing S, we know we're never getting here or here. Okay? But technically speaking, we still need to write that down. Using the language we used for extensive form games, a strategy in extensive form game is a vector indexed by information sets, even information sets that we might not get. And what we'll talk about later is how we can achieve what are called Nash equilibria in these repeated games, which again, a repeated game is just a compact particular type of an extensive form game.